few things. Let's say some function is continuous, and it is from interval a to b, and then we have g continuous, and g is from b to real numbers. So we have this b as the middle step between a and real numbers, and we can compose it like we can do g of f of x. Now question is, will this be continuous also on the interval? Well, let's see. So we can take some c inside a, and what we can do is also take a sequence an such that its limit is going to c. What we can then say is that f of an, the limit of it, is the same as f of c. And if we do the same for the argument of g, which will now be the f of x, but we know that if we take a concrete limit as x goes to as n goes to infinity for the an, meaning x goes to c, we have f of c. We can do basically something like also bn, such that the bn at limit goes to f of c, and then we have limit of g of f of c. Actually, first g of the bn is equal to g of f of c. So here, why we proved it, we have that if the two functions are continuous on the interval and we compose them, then we do get a continuous function. There's actually another way to formulate this, but this is one of the possible ways. Take some sequence, and we know that if that sequence converges at infinity to the value that we need to plug into the function, to the c that we want to put in there, then it's like putting the c there in the function, and that can be repeated also for fc as seen as a constant value. We can as a concrete value, we can then find some bn, and then if limit of bn goes to f of c, then g of bn is like g of f of c in fact.